Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of BITSAT practice, we're going to be looking at some previous year questions of the subject mathematics which were asked in BITSAT 2018. So this is the first video in the series of math questions, and today we're going to be looking at some of the math questions that were asked in BITSAT 2018 in some detail. So let's look at the first question. The first question says the points represented by the complex numbers 1 plus I, minus 2 plus 3I, and 5 by 3I on the argent plane are vertices of an equilateral triangle, vertices of an isosceles triangle, collinear, none of these. So how do we solve this question? So in order to solve this question, we need to know whether the 3 points are the vertices of a triangle or not, since that is implied as such. And if they're not the vertices of any triangle, then they are collinear. So if in order to solve this question, we need to prove that x1 y1 1, x2 y2 1, x3 y3 1 is not equal to 0 to get the vertices of a triangle, to prove that these points are the vertices of a triangle. So over here we have 1 plus I, so 1 is x1, I is y1, and minus 2 is x2, 3i is y2, and then this is y3. So if you are to find out our determinant delta, then the value of this delta is equal to x1. Let's put in the values instead of writing that again. So 1, 1, 1, 1. Actually it's minus 2 here. So minus 2, 3, 1, and 0, 5 by 3, 1. So this is the value of the determinant delta. So let's solve that. So the value of delta here is equal to, let's expand it instead of writing it like that. So 1 times 3 into 1 minus 5 by 3 into 1 minus 1 times minus 2 into 1 minus 0 into 1, and then plus 1 times minus 2 times 5 by 3 minus 0 times 3. So therefore you will have 1 times 3 minus 5 by 3, so that is 9 minus 5 by 3 minus 1 times minus 2 into 1, so that's minus 2. So minus 2 times minus 1 is equal to 2, so that is plus 2, and then minus 10 by 3, so therefore this is equal to 9 plus 6 minus 5 minus 10 divided by 3. So 9 plus 6 equals 15. Minus 5 minus 10 gives you minus 15. So 15 minus 15 divided by 3, that is equal to 0. So therefore, if you were to look at our options, you would see that option C is the correct option. And that is because if the determinant is equal to 0, the 3 points are collinear. And so therefore option C is the correct option of the first question. Next question. A and B are two non-empty sets, and A is the proper subset of B. If n of A equals 5, then find the minimum possible value of n of A delta B. So A is the proper subset of B, so that is A proper subset of B. and a and b are not equal to 0, and n of a equals 5. So now we need to know the operation a delta b. So a delta b is the quotient of a union b divided by a intersection b, which can be written down as b divided by a. So therefore n of a delta b can be taken down as n of b divided by n of a. Now, we don't know n of b yet, but we do know that n of a is given to be 5, and we also know that b is a non-empty set, and the value n can't be, fractions and stuff, so the n here corresponds to whole numbers, and a and b are not equal to 0, so therefore you can't have 0 as the correct answer. So in order to get the minimum possible value, you can take n of b as equal to 5. Since a is a proper subset of b, you can have n of b as equal to 5 and n of a as also equal to 5. So 5 by 5 equals 1. So therefore option A, 1, is the correct answer for this question, which was asked in 2018. Now we have the final question of this episode. If x, y, z are complex numbers and delta equals 0 minus y minus 2, I guess it's minus z. According to the actual question, it's minus z and not minus 2. And then y dash 0 minus x, z dash x dash 0. So this is the determinant that we are given. So what we're going to do is we're going to interchange the rows and columns. So on interchanging the rows and columns, what we're going to get here, delta is equal to 0 y z I guess it's 0 y dash z dash, and then you have minus y 0 x dash, and then minus z minus x, and then 0. So this is under the determinant. So now we take the negative out of all the 3 columns here. So you get minus 1 the whole cube times 0 minus y dash minus z dash y 0 x dash, actually it's minus x dash, and then you have z x and then 0. And so therefore you can write down minus 1 the whole cube is still minus 1, so minus delta is equal to, minus delta dash is equal to 0 minus y dash minus z dash, then y 0 minus x dash, and then you have z, x, and 0 in the determinant. So that determinant is now converted to minus delta dash. So the determinant delta originally is now determinant delta dash, I guess that's how they wrote it. Yes. So then you can write the value of delta by adding those two values. So delta plus delta dash can be written down as equal to 0, since delta is given as minus delta dash. So since delta equals minus delta dash, so therefore delta plus delta dash equals 0. And when you do that, 2 times the real value of delta equals 0. So therefore, when the real value of delta is 0, then delta is purely imaginary. So therefore, in the following question, the correct answer is option B, option B, purely imaginary, because we know that the real part of delta is 0. So basically the dash here represents the conjugate. So we found out that delta is the negative of its conjugate. So delta equals minus delta conjugate. So delta plus delta conjugate, it becomes 0. And then for, both delta and delta conjugate, the real part is same. So therefore 2 times the real part becomes 0. So the real part of delta is 0. And when the real part of delta is 0, we know that delta is purely imaginary. If you don't have a real part to a complex number, then that complex number becomes purely imaginary. It becomes an imaginary number. And that concludes this episode of BITSAT Practice. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. We have a lot of videos regarding BITSAT Practice. You can get them by hitting the link in the description box down below. If you want to access our latest content and learn more about us, then you can hit the notifications button, which is present below the video. So until the next webisode, take care, stay safe, bye-bye for now.